Hi, welcome to the video of Introduction to Matrices. In this video, we will discuss about matrices, types of matrices, addition and subtraction of matrices, transpose of matrices and product of matrices. At the end of this video, you will be able to define what do you mean by a matrix. Then you can explain types of matrices, you can add and subtract two types of matrices, calculate the transpose of matrices and calculate the product of matrices. So, let us try to understand the concept of matrices, how you are going to define matrices. So, matrices, they are actually the rectangular arrangement of numbers in m horizontal rows and n vertical columns. So, if I am saying that it is a rectangular arrangement of numbers in m horizontal rows and n vertical column, what do I mean? So, first let us see symbolically it is written as Aij, where the number I, it varies from 1 to m, and the number j, it varies from 1 to n. So, if we are going to expand this, so it takes the form A11, A12, so on up to A1n. Second row A21, A22, so on up to A2n. Proceeding in the same way, it comes out to be AM1, AM2, so on up to AMN. So, if you will look at this, so there are m rows and n columns. So, this is what we said, that matrices are rectangular arrangement of numbers in terms of rows and columns. So, if the number m is equals to your number n, then that matrix is called a square matrix. Means that when the m is equals to n, then the number of rows is equals to your number of columns. So, what do you mean by a square matrix? A matrix Aij is said to be a square matrix if suppose I varies from m to n, then j also varies from 1 to m. This means that number of rows and number of columns, they are same. For example, let us suppose this example 1, 2, 3, 4, 6, 9. Can you tell me that this is an example of a square matrix? The answer is no. This is an example of a matrix, but this is not an example of a square matrix. Why this is not an example of a square matrix? If you will count how many rows are there, there are 2 rows, 1 and 2. And how many columns are there? 1 column, 2 column and 3 column. So, it is a 2 cross 3 matrix. 2 cross 3 first always represents your rows and the second represents your column. So, it is 2 cross 3 matrix, but this is not an example of a square matrix. So, let us try to construct an example of a square matrix. For example, 1, 1, 2, 1. Here you can see that the number of rows are 1 and 2 and the number of columns are 2. So, this is a square matrix and you can write it as this is a 2 cross 2 matrix. So, knowing the concept of a square matrix, let us define some more types of matrices. Another is called a zero matrix. What do you mean by zero matrix? Any layman's idea? Yeah, the matrix where all the elements of rows and columns, they are 0, we call that matrix to be a zero matrix. So, if this is a m cross n matrix and all the elements of the rows and columns of m cross n matrix is 0, we call that matrix to be a zero matrix. So, what would be a 2 cross 2 matrix for the case of 0? This is 0, 0, 0, 0. So, this is 2 by 2 0 matrix. Similarly, we can construct so many suppose a 1 by 2 matrix. 1 by 2 means 1 rows and 2 column. So, 0, 0. So, this is 1 cross 2 0 matrix. So, this is what you mean by a zero matrix. Let's define a diagonal matrix. What do you mean by a diagonal matrix? The matrix whose diagonal elements are non-zero and off-diagonal elements are 0, we call that matrix to be a diagonal matrix. For example, consider this. Here we are taking 1, 0, 0, 0, 4, 0, 0, 0, 6. So you can see that this is the diagonal of the matrix and it is a in fact 3 cross 3 matrix. This is the diagonal of a matrix. So off diagonal elements, these are called the off diagonal elements of the matrix, and you can easily see that these off diagonal elements, they are 0. So this means that this is a diagonal matrix. Similarly, you can construct so many examples of a diagonal matrix. Let's find out a 4 cross 4 diagonal matrix. -1, 0, 2, 0, 0, 0, 4, 0, 6, 0, 0, any number, 2, 0, here also it is 0, 0, 0, 0, 5. So this is, again you can see that the diagonal elements are non-zero and off diagonal elements are 0. So this is another example of a diagonal matrix. Next matrix we are going to introduce is a scalar matrix. So what do you mean by a scalar matrix? Scalar matrix means on the diagonal elements there is a scalar quantity and off diagonal element it is 0. For example, a matrix of the form K 0 0 0 K 0 0 0 K. So here K is a non-zero number. So if such type of matrices we used to call as a scalar matrix. If the K is having a particular value equals to 1, means that if a matrix is of this form 1 0 0 0 1 0 0 0 1, then this matrix has a special name and it is called a identity matrix. So this identity matrix is actually very much useful and we are going to make use of this identity matrix more often. So identity matrix is a matrix where the diagonal elements contains the number 1 and off diagonal elements it is 0. Let's now define what do you mean by equal matrices. So let us suppose A and B are the two matrices defined as Aij, where I varies from 1 to n and j varies from 1 to m, and B is equals to Bij, where here in case this I varies from 1 to p and j varies from 1 to q. Then we will say that these two matrices are equal when the number of rows is equals to this is exactly the same as the number of rows of B, and number of columns of A is exactly equals to the number of columns of B. Means to say that when n is equals to p, m is equals to q, means that number of rows and number of columns of A and B, they are equal, they are same, and every element of each Aij is equals to Bij. Aij is equals to Bij. For example, let us suppose A is equals to 1, 2, 3, 4 and B is equals to 1, 2, 6, 3, 4, 8. Can you check that these two matrices are equal? First check, number of rows of both the matrices should be equals to number of rows of the other matrix. So for this matrix the number of rows are 2, this matrix also number of rows are 2. Here the number of columns are 2, but here the number of columns are 3. So these two matrices are not equal at all. Let us suppose C is a matrix with number of rows and number of columns of A and C are same. Let the matrix be 2, 9, 6, 8. So first check, number of rows of A are 2, number of rows of C are 2. That's fine. Number of columns of A are 2, number of columns of C is also 2. So number of rows is equals to number of rows of A and C, number of columns of A and C, they are also same. So, first check, this check is okay. The next one is every element should be equals. So, is 1 equals to 2? No. 2 equals to 9? No. 3 equals to 6? No. 4 equals to 8? No. So, A is not equals to C. So, A and C are not an equal matrix. So, if D is defined as 1, 2, 3, 4, then only we will say that A and D are equal matrices. Having the concept of what do you mean by matrices and different types of matrices, now we can move to the concept of addition of matrices. So, let us define addition of two matrices, then you can generalize the result, and in the same way you can add more than two matrices. So, let us suppose that A is equals to Aij is a matrix of m cross n order, that is I is from 1 to m and j from 1 to n, and B is another matrix Bij, and it also this matrix is also of same order, I from 1 to m and j from 1 to n, means that both the matrices are having same number of rows and same number of columns. If this condition is satisfied, then only we can move to the addition of these matrices. So, if the two matrices have same number of rows and same number of columns, then we add those two matrices, and how we are going to add? We are going to add, suppose the first element of matrices A is added to the first element of matrices B. Similarly, the second element of the matrices A is added to the second element of matrices B, and following the same procedure like that. Let us understand this with the help of a simple example. Suppose that A is equals to 1 2 1 2 and B is equals to 0 1 and 2 1. Okay. So, these two matrices are of same order, means it is of order 2 by 2. Now, we want to add these two matrices. So, what is A plus B? A plus B is this element, first element of first matrix is added to first element of the second matrix. So, 1 plus 0. This will be added to this. So, this is 2 plus 1. This will be added to this. So, 1 plus 2. So, this and this. So, 2 plus 1. So, A plus B is again going to be a matrix of order 2 cross 2, and this is equals to 1, 3, 3, 3. So, this is how we can add any two matrices. Similarly, if two matrices, this is the concept for two matrices. Similarly, you can add n or more than that matrices. Now, let us define the concept of subtraction of matrices. Subtraction of matrices is again, first condition should be both the matrices are of same order and same, they have same number of rows and same number of columns. So, once they have same number of rows and same number of columns, so just like the addition we did, we will do the same thing. Instead of addition, we will do the subtraction. So, here if you look at these two matrices, again considering the same example, so let us see how to do the subtraction. So, A minus B, this is equals to here 1 minus 0, 2 minus 1, 1 minus 2, 2 minus 1 will be your A minus B. Solve it. This is 1, 1 minus 1, 1. So, this is how you can subtract two matrices. Now, the third concept is the scalar multiplication. What do you mean by scalar multiplication? You all are familiar with the word scalar. So, actually, if we are going to multiply any matrix, let A is equals to Aij be any matrix where it is of order m cross n, means I varies from 1 to m and j varies from 1 to n. This means that it is a matrix of order m cross n. So, if you have any matrix of order m cross n and k is any scalar quantity, then if you are going to multiply this scalar quantity to that matrix, the matrix takes the form k Aij of same order m cross n. What do you mean by k Aij? K Aij means this scalar quantity, it is multiplied to each and every element of the matrix A. If I am saying that it is multiplied to each and every element of the matrix A, what I mean to say? Let us consider this example. Let us suppose that A is equals to 2, 1, 0, 2, okay? And our K is equals to number 3. So, K times A, it means that K into 2, K into 1, K into 0 and K into 2. So, what is the number K? It is 3, 3, 3, 3. This means the first term will be your 6. First row, second term, this is equals to 3. 3 into 0 is 0. 3 into 2 is 6. So, this will be the scalar multiplication of the number 3 to the matrix A. So, this is how you can define the scalar multiplication. Now, let us define what you mean by a transpose of a matrix. So, suppose you have a matrix A defined as Aij, which is having I varies from 1 to m and j varies from 1 to n. Every time when I am saying that I varies from 1 to m and j varies from 1 to n means that this matrix has m rows and n number of columns. So, what do you mean by a transpose of a matrix? Suppose you have a matrix having m rows and n columns, then transpose is actually denoted as A dash, or sometimes it is written as AT also, both having the same meaning. This means that you want to take the transpose of this matrix, or you can write it as this as T. So, what do you mean by writing this as a T? This means that the rows will convert into column and columns will convert into row. This means that now the I varies from 1 to j and the I varies from 1 to n and j varies from 1 to m. I varies from 1 to n and j varies from 1 to m means that for a matrix whose number of rows are m and number of columns are n, if we are going to take the transpose, after taking the transpose, now the number of rows will become m and the number of columns will become n. Let's understand this with the help of a very simple example. Let us consider a 2 cross 3 matrix 0, 0, 0, 1. So, this is a 2 cross 3 matrices. Here the number of rows are 2 and the number of columns are 3. So, what would be its transpose? This or this, it is one and the same thing. So, what I said that while taking the transpose, the number of rows will be your number of columns and number of columns will be your number of rows. So, this means that it will become 3 cross 2. So, how? Means that this row will now be a column. So, when this row will now be a column, it will be 2, 1, 0. Okay? And this column will become a row. So, it becomes 2, 0. Similarly, this column and this will 0, 0 and 1. So, this is how we can do the transpose of any matrix. So, the number of rows will become number of columns and number of columns will become number of rows. So, this is a 3 cross 2 matrix. So, here the number of rows are 3 and number of columns are 2. Now, let us define product of matrices. How are you going to take the product of any two matrices? Earlier, we defined a product of a matrix with a scalar quantity. Here, we are going to define the product of two matrices. So, if A is your matrix having the of order m cross n means I varies from 1 to m and j varies from 1 to n. And B is a matrix having of order n cross p. Then we can define A cross B. First thing to remember is that this is a matrix of order m cross n and this is a matrix of order n cross p. Note that if the number of columns of this matrix is equals to number of rows of the other matrix, then only we can go for the multiplication. If m and this n are not same, then we cannot go for the multiplication. So, the first and the important condition for the multiplication of two matrices is that column of the number of columns of the first matrices should be equals to number of rows of the second matrices. That is why here intentionally I have written that m cross n and n cross p. I could have written k cross p. Then I would have given the condition, if it is here a k, then the product is defined only when n is equals to k. So, if this condition is satisfied, then A cross B is equals to AI1 plus AI2 plus so on plus I is your M, so IP. Okay. So, this is in general how we are going to define the product of two matrices. You can understand this with the help of a simple example. Let us suppose that A is your 2 cross 3 matrices or 2 cross 2 matrices, 2, 1, 1, 2. Let us take a simple example, not going in more a complicated form. And B, if B is your this matrices, 3 cross 2 matrices, 1, 0, 0, 0, 1, 0, 0, 0, 1. 3 cross 2 matrix. My first question is that, can we multiply these two matrices? The answer is no. Why? Because here the number of columns is 2, but here the number of rows is 3. So, this means it does not satisfy this property. If it is not going to satisfy this property, then we cannot multiply any two matrices. So, the first thing is that the number of columns of this matrix should be equals to the number of rows of this matrix. So, it should be equals to 2. If it is 2 cross 3 matrix, then only we can multiply these two matrices. So, let us remove the last row. Okay, now it is fine. So, this is a 2 cross 3 matrices having 2 rows and 3 columns. Now, we can multiply, and A cross B is a matrix. The resultant matrix will be a matrix of order 2 cross 3. Now, look how we are going to multiply. Take this element, this into this plus this into this. So, this is 2 into 1 plus 1 into 0. This row, this column. This row, this column. This row, this column. So, this is your first term. Now, for the second term, this into this, 2 into 0 plus 1 into 1. 1 into 1. Now, this row, this column, so 2 into 0 plus 1 into 0. This is for this one. Now, we will start with this one. This into this plus this into this. So, 1 into 1 plus 2 into 0. Now, this row and this column, second row and second column. So, 1 into 0 plus 2 into 1. 2 into 1. Then second row and third column. So, 1 into 0 plus 2 into 0. 2 into 0. So, this is your 2 cross 3 matrices. And now solve it. So, it becomes 2 into 1 is 2 plus 1 is 3. 2 into 0 is 0 plus 1 is 1. 2 into 0 is 0 plus 1 into 0 is 0. So, it is 0. So, 1 plus 0 is 1. This is 0 into 2, sorry, plus 2, this is 2, this is 0, this is 0, so this is 0. So, this is the product of your A cross P. So, this is how this we did with this small matrices. In a similar basis, you can do the product for the higher orders also. But the first condition is that the number of columns of the first matrix should always be equals to number of rows of the second matrices. Key points discussed in this video are matrices, types of matrices, addition and subtraction of matrices, transpose of matrices, product of matrices. Matrices are used in almost all fields of sciences, whether it is physics, chemistry, biology or computer science. Matrices helps in making the calculation easy.